lines and angles. We're going to discuss these terms that you have in your math dictionary: perpendicular lines, parallel lines, and skew lines, as well as get into the angle measures that are created with a transversal and two lines. And lastly, we'll connect some Mod 1 vocab words with it. First example, can you name lines parallel to line CD? In order for a line to be parallel, it has to be in the same plane. A plane is a flat figure, such as DCEF. This would be a plane, and the line across from it that would be parallel would be line EF. If we think of another plane, I can connect the top portion in which line AB would be parallel. Now, our third line that's parallel isn't as obvious. The plane that we can create, or we have to envision, is connecting this corner, line CD, with line HG. And once we see that, we'll notice that line GH, or HG, is also parallel to line CD. In order to be skew, it is a line that is not parallel, but it also won't intersect. It means that it cannot be in the same plane. So if we're looking for a line that is skewed to line CD, we're looking for a plane that maybe isn't in the same realm as line CD, in which line AH comes to mind as a line that is skewed to line CD. In this plane, we also have line AG and line BG, which would also be skewed to line CD. The next plane I might look at is the bottom plane here, where if you'll notice, line FG would never intersect with line CD. It's not in the same plane, so it's considered skew. And we also have line EH, which would be, or HE, which would be considered skew. Perpendicular, we're looking for a 90-degree angle. And I see that we have line CD. A line perpendicular would be line AD. This line connects at a 90-degree angle. And this whole cube, everything, we got 90-degree angles all over the place. So this line ED would also intersect at line CD and create a 90-degree angle. Now we're going to get into our two lines, such as line A and B, cut by a transversal. The transversal is the line that connects these two lines. So the line connecting line A and B is line C. So line C is our transversal. When we have this, we're able to connect an angle from this quadrant of four angles to a quadrant, or an angle in this quadrant of four angles. So corresponding means similar position. So angle 1, an angle that's in similar position to angle 1 would be angle 5. An angle that's in similar position to angle 2 would be angle 6. An angle similar position to angle 3 would be 7. So 3 and 7 are corresponding. And our last set would be angle 4 and angle 8. If you break these down into the quadrants, these four quadrants that the lines create, when you're trying to find corresponding angles, you're trying to find the similar quadrant angle to connect. When we have two lines cut by a transversal, we have what's called alternate interior angles. Alternate meaning opposite sides or different sides of line C, and interior meaning they have to be in between the two lines, so in between line A and B. Our first set would be angle 2 and angle 7 would be what we call alternate interior angles. They're in between and they're on different sides of line C. The other set is angle 4 and angle 5. Now you can see we've isolated our four interior angles. Now we need to describe our our two sets of alternate exterior angles, which we only have four angles to choose from. So the alternate exterior angle to angle 1 would be angle 8, and our alternate exterior angle to angle 3 would be angle 6. Our next set would be same side interior and exterior angles. Same side, it refers to the transversal, the same side of the transversal. So angle 2, the same side of line C, and an interior angle would be angle 5. So 2 and 5 are same side interior. Angle 4 and angle 7 would be the other set. Now we're on to same side exterior, which we can see angle 1 on the same side and on the outside would be angle 6. And 3 and 8 would be our final set of same side exterior angles. Sometimes our diagram could be two horizontal lines and our transversal is vertical. In this figure, we had two vertical lines and the transversal was horizontal. But in this case, our angles still match up to the same. 1 and 5, 2 and 6, 3 and 7, and 4 and 8. So we can still see a diagram, even when the two lines change to horizontal, we can still connect our corresponding angles. Same with our alternate interior and exterior angles. So 3 and 6, 4 and 5, those are our alternate interior. And our alternate exterior angles would be on the outside of the two lines and opposite sides of that transversal. Same side interior, remember they're on the same side of the transversal and inside interior angles. Same side exterior angles, same side of the transversal, and they're both exterior angles, or outside of our two lines that cross. And our last reminder is supplementary angles, a linear pair, and vertical angles. We'll start with supplementary angles. So if we had angle 1, its supplementary partner is next to it, forming all the way over to this line. So a linear pair, remember it's a line pair, such as angle 1 and angle 2. You'll notice that this creates a nice half circle. If you remember, a whole circle is 360, a half circle is half of 360, or 180. As we go around these four angles, the other sets we have are 2 and 4, half circle there. Then we can connect angle 3 and angle 4. And then we can connect angle 3 and angle 1. And you'll notice as we go around, we have 4 sets of half circles as we move around, 4 sets of supplementary angles. This relationship can happen down here as well. But down here, I'm going to talk about our vertical angles. Remember, those are the angles that are across from each other, such as 5 and 8. And remember that these angles are congruent. So 5 is equal to 8, 6 is equal to 7.